A planet that shouldn't exist, the discovery that broke planet formation. For decades, astronomers believed they had finally uncovered one of the universe's simplest rules. Rocky planets belong close to their stars, while gas giants belong far away. It wasn't just true in our own solar system, it appeared everywhere we looked. Thousands of planetary systems seemed to follow the same blueprint. Then, in 2026, scientists found a planet that completely ignored the rule. A rocky world orbiting where only a gas giant should exist, and the single discovery may force astronomers to rethink how planets are born. Every planetary system begins the same way. A young star forms inside a massive cloud of gas and dust, surrounded by a spinning disk of material. Tiny grains collide, stick together, and over millions of years grow into rocks, mountains, and eventually entire planets. But one invisible boundary determines what kind of planet can survive. Astronomers call it the snow line. Inside this region, temperatures are so high that intense radiation from the young star strips away lightweight gases before forming planets can hold onto them. Only dense, rocky worlds remain. That's why Mercury, Venus, Earth, and Mars are all made mostly of rock. Beyond the snow line, temperatures drop, gas survives, and planetary cores rapidly gather enormous amounts of hydrogen and helium, growing into giant worlds like Jupiter and Saturn. For years, this pattern appeared to be universal. About 116 light-years from Earth lies a faint red dwarf star known as LHS 1903. Red dwarfs are small, cool, and dim, yet they are the most common stars in the Milky Way. When NASA's TESS mission first observed this system, astronomers identified 3 planets. Everything looked perfectly normal. The closest planet was rocky, while the next 2 possessed thick gaseous envelopes, exactly what existing theories predicted. Nothing seemed unusual. Years later, researchers took another look at the data. Buried within the observations was evidence for a 4th planet. At first glance, it didn't seem remarkable. It orbited farther from the star than the other 3, moved more slowly, and was only slightly larger than Earth. But when scientists calculated its density, everything changed. The planet wasn't made of gas. It wasn't an ice giant. It wasn't wrapped in a thick atmosphere. Instead, it was almost entirely rocky. A super-Earth located in a region where a gas giant should have formed. Astronomers had never seen anything quite like it. The discovery immediately raised an important question. How did it get there? The first possibility was planetary migration. Perhaps the planet formed close to its star before moving outward. After all, giant planets are known to migrate, and even Jupiter may have shifted position early in our solar system's history. Researchers ran detailed computer simulations, but none of them worked. The planet could not reach its current orbit without either being ejected from the system or destroyed. That explanation failed. The second possibility was atmospheric loss. Maybe the planet originally formed as a gas-rich world before somehow losing its atmosphere. Once again, the evidence disagreed. The planet sits too far from its star for radiation to strip away such an enormous atmosphere, and there was no sign of the catastrophic collision that would have been required to remove it. 2 of the strongest explanations had collapsed, leaving astronomers searching for an entirely new idea. The answer may lie in timing. Most models assume that all planets begin forming at roughly the same time. But what if they don't? What if planets grow one after another instead of all at once? Imagine the inner planets forming first. As they grow, they consume huge amounts of gas from the surrounding disk, while radiation from the star gradually disperses even more material. Millions of years later, when the outer planet finally begins to form, very little gas remains. Only rock, only heavy elements. Instead of becoming a giant gas planet, it slowly grows into a rocky super-Earth. Astronomers call this process gas-depleted formation. For years, it existed only as a theoretical possibility, but LHS 1903e may be the first real-world evidence that it actually happens. At first glance, one unusual planet may not seem important, but discoveries like this have transformed astronomy before. Every major scientific theory begins with patterns, and every revolution begins with an exception. For decades, scientists used our solar system as the standard model for every planetary system in the universe. Now that assumption is becoming harder to defend. If rocky planets can form far beyond where we expected, then many planetary systems we've already observed may need to be reinterpreted. Even more exciting, there could be thousands of rocky worlds hiding in places astronomers never thought to search. Not because they were invisible, but because our theories convinced us they couldn't exist. LHS 1903 may not be the largest planet ever discovered, the most beautiful, or even the strangest, but it asks one of the most important questions in modern astronomy. Have we misunderstood how planets are born? If the answer is yes, then somewhere in our galaxy, countless undiscovered worlds may be waiting to rewrite the rules of planetary formation once again. And perhaps this is only the beginning.